Okay.
Are you all able to hear me?
Yes.
Okay, today we're basically going to continue with yesterday's session. A few subtopics are still left. We're going to discuss today regarding molecular formula and percentage purity and percentage yield. Okay. If you look into this, how do we actually use the data to find out the molecular formula? If you look into this question, the empirical formula is given to you. Okay. Yesterday, if you remember, how do we find out the empirical formula? We first use the mass, which is given to us, or the percentage composition by mass divided by their relative atomic masses or their molar masses to find out the number of moles. Once we get the number of moles of all the atoms or elements which are present in in the compound, we take out the simplified ratio, and by dividing all the number of moles by the smallest number out of them. Okay, as a result of which you are going to get the simplified whole number ratio, which is referred to as your empirical formula. Now, once you have the empirical formula and you have been given the relative molecular mass or the formula mass of that substance, and you have been asked to find out the molecular formula, what are you going to do here? You are going to first find out the empirical mass. What is the empirical mass? Empirical mass is the mass of this particular compound, which is basically the empirical formula of that compound. So it is going to be 12 times 4. Why? Because you have 4 carbon atoms plus 1 times 10. The relative atomic masses or their relative atomic masses, they have to be multiplied by the number of atoms which are present here in this empirical formula. So it's going to be 12 times 4 for carbon atoms. Then you're going to add up 1 times 10 for hydrogen plus sulfur. There's only one sulfur, so it's going to be 32. Relative atomic masses, they are already given to you in the periodic table. So you would refer to the periodic table, okay, for this. Then you're going to sum it up. What is the answer for this one? 48 plus 10 plus 32 is going to be
130.
how much? 20? 40?
130.
No, I didn't get you. Sorry, can come again?
130.
130. Okay, thank you. So 130 is basically the empirical mass of this compound, okay, for the empirical formula which is given to you. And you have been asked to find out the molecular formula. Molecular formula is basically the constant multiplied by the empirical formula. Now this constant is going to come up by division of the molecular mass divided by the empirical mass. Okay. So it's going to be 180 times 180 divided by 130. What is the answer?
1.38.
1.38. Wait, did you sum it up correctly? Is it 12 times 4? 48 plus 10 plus 32? 90 should be the answer. No? It should be 90. When you sum it up, 12 times 4 is 48. 48 plus 10 plus 32, which is going to be 90. 180 divided by the empirical mass, which is 90. So you would get 2 as the constant. This 2, which is the constant, you're going to place it here within the formula, multiply it by the empirical formula, which was given to you earlier in the context of the question, but that is C4H10S. Okay. And then you're going to multiply it. What is the final answer? C4 will become C8. 4 times 2 is 8. Hydrogen becomes 20 and sulfur becomes S2. Okay. This 1 is multiplied by this constant 2 to give you S2. All right. This is going to be the molecular formula. This is the molecular formula for that compound X, which has the relative formula mass of that is 180. And even if you sum up all their atomic masses, you will get this relative formula mass that is 180. Is this point clear?
Yes, miss.
Okay, next we move on to hydrated salts. Hydrated salts are basically crystallized salts. A salt where some of the water molecules, they are retained within the structure, hence changing the shape of the structure and also changing the color of that hydrated salt. Okay. So hydrated salt, how do we represent hydrated salts? In hydrated salts, you will see supposedly it separately shows those amount of water of crystallization or that hydration level. How is this represented? After the period. After the period, the number of moles basically tell you how many water molecules are basically incorporated within this hydrated salt. So means that if you look into this, the ratio of copper to sulfate to water molecules is 1:2, okay, within this hydrated salt. And this is 1 mole of, this is going to be 1 mole of copper to sulfate hydrated crystal. All right. This degree of hydration can change. Okay. This degree of hydration can change, which means that it can also be 5H2O. For instance, if you have cobalt chloride, it can be 4H2O. All right. This means that the degree of hydration is actually changing. It is varying. Okay. Or 2H2O or 6H2O. Okay. Representing that this is the water of crystallization which is present within this hydrated salt. If any number is written adjacent as a coefficient to this number, for instance, 2, 3, 4, anything else written just adjacent to the chemical formula, this means that this is 2 moles of copper to sulfate hydrated crystal. Okay. But the formula of hydrated salts is determined experimentally as well. How? By weighing that sample of hydrated salt, and then when you reweighed that anhydrous salt, you get to know the actual amount of water which has been evaporated. Okay, hence you are able to identify the amount of water molecules which are basically present within this hydrated salt. So this is some other part of the story. We will do this when we go through preparation of salts and all. And whenever any question comes up where they ask you to find out the hydrated salt and the water molecules, for instance, they write XH2O. You are asked to find out the amount of water molecules which are present. You simply have to use the same method that we discussed regarding the empirical formula. Okay, how do we do that? Now, for instance, the question says 11.25 grams of hydrated copper to sulfate. This means that this is total 11.25 grams. It is heated until it loses all of its water of crystallization. And when it is reweighed, its mass is 7.19 grams. Okay. Now, this means 7.19 grams means this is the mass of the anhydrous salt. Okay. Anhydrous salt means which does not have basically means anhydrous means that hydrous refers to water, okay, water molecules. So no water molecules are present within this salt. When no water molecules are present, the formula tends to be CuSO4, okay, for copper to sulfate. All right. So the mass of copper to sulfate which is left behind is 7.19 grams. Am I clear so far? Yes. Is this point clear?
Yes.
Yes,
Okay.
miss.
Now, when you look into this, the mass which is given to you for copper to sulfate hydrated salt is 11.25 grams, and the mass only for copper to sulfate which is given to you is 7.19 grams. And what do we have to find out? We have to find out the number of moles of this, okay, or the value for X, the hydration level of water molecules present, water of crystallization which is present in this hydrated salt. What do we do here? We're going to look into them separately. Copper to sulfate is 7.19 grams. If you use their amounts in mass, by mass. And for water. Now, how do I get the mass of water which is given to, which is present within this compound? 11.25 minus 7.19 will tell you the mass of water which is present here. Okay. What is it going to be? 11.25 minus 7.19. Subtract the mass of anhydrous copper 2 sulfate from the hydrated salt's mass.
4.06.
4.06. So 4.06 grams of water molecules, water is basically present within the hydrated salt. Okay. Now, what is the next step? When you already know the mass now, we find out the number of moles. How do we find out the number of moles? Mass upon molar mass. And molar mass for copper 2 sulfate is going to be its relative molecular mass. What is it? 63.5 plus 32 plus 16 times 4. And for water, it is 18.
Bad. 159.5.
159.5. So this is the molar mass of copper 2 sulfate. Can you also divide this to tell me the number of moles?
0.256.
0.256 for which one? 7.19 divided by 159.5.
Oh no, sorry, I did for H2O.
Okay, for H2O. For H2O it is?
It is 0.2256.
0.2256. 2256 or 0.226. Okay.
Okay, and ClSO4 is 0.045.
0.045. Okay. Now, once we get the number of moles, all right, what are we going to do? We're going to look into which one is the smallest number. Which one is the smallest here? 0.045, right? We are going to divide both of these numbers by 0. The smallest number out of the two, and which gives 1 for copper 2 sulfate. And what about for the water molecules? 0.226 divided by 0.045 will be
5.02.
5. Okay, 5.02, which is going to be 5. All right. So this means that the value for x is basically this. This is the number of water, and 1 is the ratio of copper to sulfate. So 1:5 is basically copper to sulfate ratio of water. So the value for x is going to be 5. Hence, the formula of hydrated copper sulfate, which will be which you're going to write at the end, is going to be CuSO4.5H2O. Okay. Moving on. Now, when we're discussing about the percentage yield, do we have any questions so far?
Miss, what's the answer again for X?
For X, it is 5.
Okay, so we just ignore the one, right?
Ignore which one?
The number 1 is for CuSO4.
No. Yeah, it is for CuSO4. They asked for the formula of the hydrated copper 2 sulfate, so it is going to be CuSO4.5H2O.
Okay.
This means, this basically tells you that the both of these copper 2 sulfate and water, they are in the ratio of 1:5. Are we clear?
Yes.
Okay. Moving on to the next one. So yield is basically the amount of product which you get after a reaction. Okay. And it is important to find out the percentage yield of the product which is formed. Why? Because of economical purposes as well, also to look into various other things. All right. For instance, there might be a possibility that there is some um, some ambiguity within the chemical process, or how it is actually carried out, or there might be some other things which are going on. For instance, that once you are shifting the product from one vessel to another reaction vessel, there is a possibility that you lose some of the product. So it is important to find out the percentage yield. Whenever such questions they come up, you have been given by the examiner the actual yield. You simply have to divide by the theoretical yield and multiply it by 100 to convert it into percentage. Okay. Actual yield is usually given by the examiner. Theoretical yield is the one that you have to find out, and obviously you have to find out by the by using the molar calculations which we did in the previous other questions, right? For instance, if you look into this question, it says copper 2 sulfate is prepared by the reaction of sulfuric acid with copper 2 oxide. Okay. So a basic oxide reacts with an acid. A student prepared 1.6 grams of copper 2 sulfate crystals, and the percentage yield has to be calculated if the theoretical yield is 2 grams. All right. So what are you going to do here? Can you figure out what is the actual yield? In the context of the question, can you figure out what is the actual yield?
1.6.
Yes, 1.6 grams. Very good. Just like this. Okay. So 1.6 grams is basically the actual yield. The actual yield is, it is dire that this actual yield has to be less than the theoretical yield. Okay. The theoretically you get the amount is basically your upon all the assumptions and presumptions which are taken place. But when you experimentally do that particular chemical reaction, you undergo an experiment, the actual yield which turns out to be, or the amount of product which is received or produced at the end, comes less as compared to the theoretical yield. So actual yield divided by the theoretical yield will be multiplied by 100 to convert it into a percentage yield. Theoretical yield given to you, which is 2. 1.6 grams is the actual yield, and you simply divide by 2, multiply it by 100 to give you the final answer. Okay. And you can see in the question as well, as it says a student prepared 1.6 grams of this. This context basically tells you that this is going to be your actual yield. Okay. Moving on to the next one. If you look into this, some questions also come up where they say that you have to find out the percentage composition of a particular element. So what do you do here? You basically take the total mass of that element which is present in the compound and divide it by the total molecular mass or the formula mass of that compound. And since you have to convert it into a percentage, you multiply it by 100, then you will be able to know the percentage composition of that particular element. For instance, if I say that you have water, okay, the percentage composition of hydrogen, if it has to be found out, then the mass of hydrogen here is, there are 2 atoms of hydrogen present in one water molecule. So 1 times 2 relative atomic mass of hydrogen multiplied by 2 atoms of hydrogen divided by the total mass. The total mass of this whole molecule is 18. And then you multiply it by 100 to find out the final answer. For oxygen, it is going to be, there's only 1 oxygen atom. You're going to simply use the relative atomic mass of oxygen divided by 18 and multiply it by 100, okay, to give you the percentage composition of that particular element within the compound. All of these percentage compositions of all the elements which are present within the compound, if you sum it up, you will get a total of 100%. Okay. For instance, there are certain questions which come up. For instance, if they say ammonium nitrate, okay, and you have to find out the percentage composition of nitrogen here. Okay, can someone tell me the percentage composition of nitrogen in this compound? Percentage composition of nitrogen in this compound.
Is it 0.35?
0.35. No. What are you doing?
35%.
Oh, I forgot
30.
to multiply by 100.
You multiplied. We did multiply. Yes, that's right. Okay. What did you do?
I forgot to multiply the answer by 100.
And before that, what did you do?
I did 14 plus 14 divided by 14 plus 4 plus 14 and 2 times 3.
Yes, that's right. Okay. Moving on to the next one. Now, how do we find out the percentage purity? Percentage purity is also very important to find. Why? Because supposingly certain processes, chemical reactions which are carried out, they are industrial processes, okay, or ones which are which need to market their own product, right? So that product which has to be released within the market, if supposingly it is a contaminated product or has any unwanted substances or has greater amount of impurities which are present, then it is that particular product batch is not released in the market. Okay. So, which is why percentage purity is important. It basically tells you how pure the substance is, okay, or how impure that substance is. If the percentage purity is approximately nearer to 85% or 90% or 95, this means that the percentage purity is good enough, okay. The mass of the pure substance is written as a numerator, and total, it is divided by the total mass. This total mass is also the impure mass, okay, and then you multiply it by 100 to convert it into percentage. All right. So for instance, if you look into this example here, it says that a sample of lead to bromide was made, which is weighed 15 grams. The sample is found to be impure and contained only this much amount of lead to bromide. This means that this is the pure mass. Okay, this is the pure mass, and this one is the impure mass. All right. Now you have to find out the percentage purity of lead to bromide here. So pure divided by impure multiplied by 100. Okay. So it is going to be 13.5 divided by 15 grams multiplied by 100 to give you the final answer. Am I clear so far?
Yes, miss.
Any questions up till yet?
Miss, sometimes in the question they give like isotopes. I don't know if it's related to this lesson, but there was one question where it's saying like silver with a mass of 107 and silver with a mass of 108. So we should find the purity.
And then find the.
And then wait, no, I forgot the question. I'll get back to you after I remember it.
Okay. Otherwise, you can simply text me on WhatsApp. Okay. Let me check if I am able to. Let me skim read some of the past years. Wait. One questions which are related to isotopic abundances, they are that you have to use them to, which we also did in this topic, where you have to find out the relative atomic mass of a certain substance using the relative isotopic abundances. Okay, over there you simply have to multiply. But if there is any other question, do let me know.
Okay.
All right. Okay, now we're going to begin with electrochemistry. Is the PDF visible?
Yes, miss.
Okay. So in electrochemistry, what you have to understand a few basics, few rules of electrolysis, and then you should be able to find out the products and their produced at the two electrodes, the half equations, ionic equations. They are important. Okay. So basically, when you go through this topic, this is basically the study of those chemical reactions which undergo the process of electrolysis. Okay, and if you look into this terminology that is electrolysis, you see that you break down this terminology into two parts: electro and lysis. Okay, electro refers to electric current. All right, whereas lysis means breakdown. Okay, so there is breakdown of an ionic compound by the passage of electric current. Okay, so there is breakdown of an ionic compound by the passage of electric current. This process is referred to as electrolysis. So why are we only referring to ionic compounds here? Why not any covalent? We have discussed about the chemical bonding of ionic compounds and the covalent compounds and all. We know that metallic metals or those elements which have metallic bonding, they basically, and they are able to conduct electricity. They are good conductors of electricity. Why? Because they have, yes, anybody. Why are metals good conductors?
They are mobile electrons.
Delocalized electrons. Okay, they have delocalized electrons, and ionic compounds, they are able to conduct electricity because
Anions and cations.
yes, because they have free moving mobile ions. Okay, so whenever we're discussing about ionic compounds, we say that they have mobile ions only which are present within the molten state, not in the solid state. Okay, molten state or in aqueous state, where the ionic compound is basically added into water and it dissolves, so it dissociates to produce its positive ions and negative ions. That is cations and anions. Okay, so as a result of these free moving ions, the ionic compound is able to conduct electricity. But it is vice versa in the solid state. In a solid state, ionic compounds, all the ions, they are arranged in an alternating pattern, which is why they are not able to carry electric charge. As a result, they are unable to conduct electricity. Also, when we look into covalent compounds, they're also not able to conduct electricity. Hence, covalent compounds can also not undergo the process of electrolysis. Okay, why? Because they do not have any ions which are present. So basically, you need either delocalized electrons or mobile ions for any substance to act as an electrolyte. Okay, now what is an electrolyte? Electrolyte is basically a substance which is a solution, okay, which is going to conduct electricity. Okay, and here when we're going to discuss in electrolysis in electrochemistry, we will be discussing usually the ionic compounds which will be in their molten state or dissolved state in aqueous state, which will be acting as an electrolyte. Okay, can someone tell me that if whether there are any other substances which are able to conduct electricity, or can acids conduct electricity? Can acids conduct electricity? Can they
Yes,
behave? Can they behave as an electrolyte? Yes. How?
they can dissociate to form ions.
Yes. Very good. Very good. So acids, they are able to conduct electricity because they are able to dissociate into ions. For instance, if we look into hydrochloric acid is able to dissociate in its aqueous state in water when it is dissolved in water. It dissociates to form hydrogen ions and chloride ions. Okay, whereas, and this is a complete ionization. All right. Whereas any weak acid, for instance, ethanoic acid or any organic acid or any other carbonic acid or any other acid, which is a weak acid, they usually have partial ionization. As a result, this means some of the molecules that they tend to produce their acid part, their hydrogen ions, and produce their negative ions. And this is a reversible reaction, which means that the amount of hydrogen ions which are produced as a result of ionization when they dissolve in water for any weak acid, then this is going to be the concentration which is produced is basically less, okay, for hydrogen ions which are produced. So the weak acids, they tend to have less electrical conductivity, whereas strong acids, they are good electrical conductors, okay, because of their irreversible reaction, because of their production of complete ionization of the hydrogen ions, okay, and their relative subsequent ions, okay. If you look into a simple electrolytic cell, is this point clear? If anything is not clear so far, do let me know. Yes, Ayla and Ahmad, Ibrahim.
Yes, miss, it's clear.
No questions.
Okay. All right. When you look into this, in a simple electrolytic cell, there is a power pack or a DC supply. This can be represented as this, or a simple battery terminal with positive and negative terminals. Okay. These are connected with the connecting wires and to the pieces of electrodes. These pieces of electrodes, they can either be metal rods or they can be graphite inert electrodes, and they tend to carry electric current into and out of the electrolyte. Okay, and they are then dipped into the electrolyte, which is your molten or aqueous ionic compound solution. Okay, molten or aqueous ionic compound solution. Now, this DC supply or the power supply, which is connected, or the positive terminal, which is connected to the electrode, tends to be the positive electrode, and this one is going to be your negative electrode. The positive one, how do we remember it? It is going to be your positive anode, and negative is going to be your cathode. So negative is cathode. Hence, you get the mnemonic, which is panic. Okay. Positive anode and negative is cathode. Now, is this point up till yet clear so far?
Yes, miss.
If you look into this, supposingly I say you have sodium chloride, and sodium chloride is in its molten state. So I'm going to write liquid with lowercase l with NaCl. This means that what ions are present here in sodium chloride, molten sodium chloride is going to be sodium ions and chloride ions, right? Positive ions, they are going to be, or your cations are going to be attracted towards the cathode. And the negative ions, which are the anions, they are attracted towards the anode, since we know that the opposite charges, they attract each other. So this means when both of them, they are attracted towards the cathode and the anode respectively, what is going to happen? Cations are attracted towards the cathode. They are going to accept the electrons which are coming in from the negative terminal of the battery. So look into the flow of the electrons. The electrons are actually coming from They're incoming from the negative terminal of the battery towards the cathode. Okay, but there is no flow of electrons within the electrolyte. There is no flow of the electrons within the electrolyte. There is only ions which are moving within the electrolyte. Okay, so sodium ions, they have deficiency of electrons, or do they have an excess of electron? Yes, sodium ions, do they have an excess of electrons, or do they have a deficiency of electrons?
Deficiency.
Yes, how much?
One.
Yes, very good. One electron is deficient, no? Because it says plus, 1 plus. This means that there is only one electron which is deficient. Now, these electrons which are incoming into the cathode, these electrons will be accepted by the sodium ion, which is already deficient in an electron. So it is going to gain that one electron to produce sodium metal. Okay. And this sodium metal will be deposited onto this cathode. Am I clear? Is this point clear so far?
Yes, miss.
What about the chloride ions? Chloride ions, they are attracted towards the positive anode. Since they are negative, so they are attracted towards the positive anode. They have an excess of electron. How? Negative means they have excess of electron. How many electrons are in excess? How many electrons are in? 1. So they are going to lose that 1 electron, give away that 1 electron. So the electron flow tends to be outgoing from the anode and incoming from the negative terminal towards the cathode. So it's always towards the cathode and away from the anode. Towards the cathode and away from the anode. So chloride ions, they lose that electron to produce chlorine gas, since it exists as a diatomic molecule. So we have to balance this on both the sides. This means that 2 chloride ions, they are going to lose one electron each, which means a total of 2 electrons are lost by 2 chloride ions. Hence, to produce chlorine gas, which is evolved or produced or observed or seen at the positive anode. And since we know that chlorine gas has a green color, so that it is observed as green gas evolving at the or evolved at the positive end. Is this point clear so far?
Yes, miss.
Now, if you look into these two reactions are basically the half equations or ionic half equations to represent the reactions taking place at the cathode and at the anode. We know that sodium is deposited, so sodium metal is deposited as a solid, and both of these ions, they're going to be in the liquid state. Obviously, no state symbol has to be written with the electrons, okay? And chlorine is deposited as a gas, or it is produced as a gas, okay? This is going to be your ionic equation for this particular reaction or electrolysis of molten sodium chloride, okay? Now, if a complete ionic equation has to be written, what are you going to do? You must look into that the number of electrons must be balanced on both the sides. They're not balanced, right? At one half equation, you have 1 electron. On the other side, you have 2 electrons. So this should also be 2. If this is 2, this means I must multiply all of them by 2. So this makes it 2 sodium ions. They accept 2 electrons to produce 2 Na, okay? So the complete equation is going to be, you're going to cancel these 2 Na plus 2 chloride ions to produce 2 Na plus Cl2. Okay, is this point clear? This is the complete ionic equation for this reaction. The state symbols are going to be for ions, since it is molten. If it was if it would have been aqueous, then you would have placed aqueous. This is going to be solid. This is going to be gas. Okay. I hope I'm clear so far. Do we have any questions up till yet?
Miss, how is it liquid? Shouldn't it be like aqueous or something?
Where?
For NaCl.
No, this is molten electrolysis of molten sodium chloride. No? For aqueous sodium chloride, the products they are going to be completely different. Sodium is not even produced as a product. No? For aqueous sodium chloride, we are going to come up to that.
Okay.
For now, we're discussing about the molten. This is what I'm trying to convey, that we are discussing molten sodium chloride. In molten sodium chloride, we don't have any water which is present, right? It is the ionic compound which is melted down to produce the molten liquid state of the ionic compound, that is NaCl. Okay, there's no water which is present. So the only sole ions which are present, they are sodium ions and chloride ions. Hence, you have to write lowercase l with the ions. But if supposingly the question says that these are, supposingly you have been given copper to sulfate, aqueous copper to sulfate, or any other aqueous solution, aqueous dilute aqueous sulfuric acid, okay, then all the ions which have to be written, they will be written as AQ.
Okay.
Yes, moving on to the next one. Is this point up till yet clear so far regarding how to find out how to write your half equations, how to find out the products, what would be the observations? Clear?
Yes, miss.
Okay, when we look into this, the metals and the hydrogens, they are usually formed on the, and they're deposited onto the cathode, whereas the non-metals, they tend to be deposited at the anode. Okay, metals and hydrogen, they are positive cations, which is why they are deposited onto the cathode. So cations are deposited onto the cathode. Cathode is the negative electrode. Non-metals, they tend to be deposited on the anode. Why? Because they are negatively charged. Negatively charged are always attracted by the positive anode. Okay. For instance, if you look into this one, this is the electrolysis of molten lead-2 bromide. Here they say that first, lead-2 bromide is placed within a beaker. It is heated so that it turns molten, and allows the ions to be freely mobile so that they're able to carry electric charge. And there is 2 graphite rods which are placed or dipped as electrodes within the electrolyte, and they're connected to the power pack or the battery. Then the power pack or the battery is turned on and to allow the electrolysis to take place. These graphite rods, they are the inert rods. What do we mean by inert?
Unreactive.
Unreactive. Okay, this means that they do not take part in the process of electrolysis. They are unreactive completely. Other than graphite rods, there can be carbon rods. Graphite is also carbon. Platinum rods, which can be used as your electrodes. Okay. So the one use of graphite is, we also studied in covalent when we were doing macromolecules, one use of graphite is that they are used as electrodes, right? Now, if you look into the observations, the negative bromide ions, since they're negatively charged, they're going to move, or they're going to be attracted towards the anode, which is positively charged. They're going to lose one of their electron to form bromine molecules. There is bubbling at the anode, which is seen. Now, whenever the examiner asks you to write the observations at the anode and at the cathode, observations, they involve writing what is observed by your naked eye, okay, what you see in the experiment. So not to ever mention the bromine gas is produced or lead metal is produced, no. Mention what are the characteristic features of that particular substance which is produced at that electrode, okay. For instance, here in this case scenario, you will mention brown gas is given off at the anode. This is enough, or bubbles of gas are seen or observed at the anode. If you know the distinctive color of that gas, mention it. It is going to be good enough. If you supposedly don't know, don't remember, don't recall what will be the color of that particular gas, then just mention bubbles of gas are seen or observed, or it is given off. Okay. And for the positive lead ions, they move to the cathode. They gain electrons which are incoming from the negative terminal of the battery to form the gray lead metal, and this deposits onto the surface of the electrode. Can someone tell me the ionic half equations which take place at the anode and at the cathode? What will be the ionic half equation for both of them?
Miss, bromine is -1, right?
Bromine is negative?
1.
-1. Yes, it is in group 7.
Okay.
Hmm.
So can we say 2 Br minus
2 Br minus.
and then arrow
Okay, arrow.
Br2 plus 2 electrons.
Plus 2 electrons, yes. So this basically means that two bromide ions, they are attracted towards the anode. They lose 2 electrons. You can either mention 2 electrons on the left hand side with the bromide ions, or you can mention it with the a product. If you mention it with the product on the right hand side, mention it with as +2. If it is written on the left hand side of the equation, you have to mention as -2e. Then you won't be mentioning here. Okay. But both of these ways, they are absolutely correct. Then this production of the bromine gas. What will be the state symbol? What will be the state symbol here? Bromide ions are present in molten state. Okay. So the liquid L is written, and for gas, it is going to be small lowercase g. Okay. What about the at the cathode? Yes, you can also write in the chat box. What will be the reaction ionic half equation for at the cathode? It is going to be, if you look into this, lead ions. Are you not able to get this part? Is this too difficult? Or what part is not understandable?
Miss, shouldn't it be? Oh, okay, never mind.
What?
Never mind.
Okay, lead 2 ions, they are attracted towards the cathode. They accept 2 electrons and are deposited as solid lead metal. Okay, so the observation tends to be that gray solid is deposited onto the cathode. This is your observation. And when they ask you to identify the substance which is formed or produced, then you're going to mention that, or what are the products, then you're going to mention that. At the anode, bromine gas is produced, and at the cathode, lead metal is produced. Is this point clear so far?
Yes, Miss.
For everyone else too? Ayla, Ahmed, Basit, Ibrahim, Misha, Hamdan.
Yes.
Miss, so at the
Yes.
cathode, we just say that a gray metal is deposited at the cathode.
Yes, gray metal is deposited at the cathode. For any observations, whenever you're asked to write down an answer for an observation, you simply do not mention the that this particular substance is formed. When the examiner is asking, the examiner basically wants you to know that what are the characteristic features of that substance which is produced. Okay, they're not asking you to identify that substance. The identification of that substance is going to be completely, the question is going to be completely different. For observations, it is required that you mention that the bubbles of gas are seen or observed. What are you observing from your own naked eye? Okay, that is what you have to write. Obviously, when you're looking at the substance which is produced at the anode, okay, or at the cathode, you're not able to, just by looking at it, you're not able to identify that it is bromine or it is lead or not. You have to simply mention that brown gas is given off or evolved, it is produced at the anode, or bubbles of gas are given off or seen or observed at the anode, and gray solid is deposited onto the cathode. That is going to be your observation. Okay.
Okay.
All right. I will be ending the session till here for now. Tomorrow we will continue with this one. And if anyone has any questions regarding moles, stoichiometry, anything, so you can ask me, text it on the WhatsApp, either text me separately. I will answer your queries. Okay.